All right, this is problem 3.6.37, and they're asking us to determine whether this statement is valid or not. And the statement, we have all birds are reptiles, all reptiles are descended from dinosaurs, therefore all birds are descended from dinosaurs. And in the problem in my math lab, they're actually asking you to determine the validity, but also the form of the validity, and that's not something I'm requiring you guys to know for the exams. It's something that you have to do on the homework because there's no other way to choose those homework problems for you. But you can look that up. So, for instance, this is actually going to end up being valid by transitivity, but I don't care that you know that it's valid by the actual transitivity. What I would like for you to be able to do is be able to create the statement, so identify some variables here that go with each of these statements, convert that into a logic symbols and a logic statement that then you can use in a truth table to determine the validity. So instead of memorizing things, I want you to be able to understand how to do a truth table. Okay, so let's actually run through this example using that. Okay, so the first thing we're going to do is we're going to define some variables here for what's going on in the problem. So if we look at this, if we let P be all birds, because the first statement here actually has two things in it. It has birds and it has reptiles. And when it says all birds are reptiles, if we allow P to be birds and then Q to be reptiles, we've separated those two things. And this first sentence then could actually be thought of as a conditional, as an if-then. So if it's a bird, then it's a reptile. That all birds are reptiles and that statement, that if-then statement I just mentioned, are the same. And then we'll let R be all, basically anything that's descended from dinosaurs. Okay, so if we look at our premises, so the first premise would be coming from this first sentence right here. And like I was saying, all birds are reptiles is the same thing as saying if it's a bird, then it's a reptile. So we can talk about that first sentence being translated into a conditional of P implies Q, the way that I have things defined there. And the second sentence, all reptiles are descended from dinosaurs, that's the same thing as saying if it's a reptile, then it's descended from dinosaurs. So our second premise, if it's a reptile, that would be Q, then it's descended from dinosaurs, that would be R. Okay, and the conclusion here is, so therefore, that tells us this is our conclusion, all birds are descended from dinosaurs. So the conclusion, if we say all birds, we're talking P, and then if we're being descended from dinosaurs, that's R. And again, in the conditional form, if it's a bird, then it's descended from a dinosaur. So this would be P implies R. Okay. So this is how we're taking this and we're creating these logic symbols with it. And then now we need to actually look at how we would stick this into a truth table. So remember that you're always going to combine your premises with a conjunction, and you always combine your premises and your conclusion with a conditional. So it'll look like this. We're going to have P implies Q and Q implies R. So all of that is our premise, basically. Notice the use of parentheses here because the use of parentheses is important. I've got to do this conditional, then I'm taking the conjunction, and the brackets here mean I need to do all of that before I look at how that joins with the conclusion. So always your premises are joined with a conjunction, and your premises and your conclusion are joined with a conditional. Okay. All right, so now what we're going to do is we're going to go ahead and stick this into a truth table and just see what we end up with. You will find that this is going to be valid, and it's valid by transitivity, the property of transitivity. Okay, but let's actually show that. All right, so what I'm going to do here, create my top part of my column, my chart. So I have P, Q, and R. And since we have 3 different variables that we're working with, we're actually going to have 8 different rows here. Okay, so we'll start with 4 trues in a row and 4 falses in a row for the P. And then the Q is going to go true, true, false, false, true, true, false, false. And R is going to oscillate true, false, true, false, all the way down. And that will take into account all of the different scenarios for combinations of P, Q, and R. Okay, so let's go ahead and actually, before we do any more, let's go ahead and build the rest of this in our chart. So we're going to want to do a P implies Q column. And then we're going to need to do a Q implies R column. And then we can combine those two. So then we can take a look at the P implies Q and Q implies R column. Then we're going to need P implies R. And then we can bring this entire thing together. So this would be P implies Q and Q implies R. Whole thing conditional with P implies R. Okay. All right, so one second here. So remember that on exams, you'll be given a formula sheet, and this is what your formula sheet's going to look like. So you'll be given the truth tables, and we're going to be using these truth tables to then finish this truth table right here. Okay, so if we look at our conditional truth table, because our next thing is we want to fill out this column, with P implies Q, the only time you have a false is when you have a true and then a false in that order. Okay, so what I'm going to do is I'm going to look for the true and the falses. So P implies Q, I'm looking at these two columns right here, and anywhere I've got a true and then a false, I'll end up with a false here, and everything else is going to be true. And that's the quickest and easiest way to go about determining what your truth values are here. Okay, so I'm going to do the same thing for Q implies R. So Q implies R is these two columns right here. Okay, so if I look at these two columns, if I see a true and a false right there, I see one, that'll be false. So that's this one and this one. True and false gives me false. And I'm going to look for any others. There's a true and a false. So that's going to be false. And then everything else will be true. Okay. All right, so now what we're going to do is we're going to take the conjunction of this column and this column to get this column. Okay, so remember that the conjunction truth table, the only time it's true is when you have two truths. Other than that, you're going to have everything be false. So let's look for the truths. So we have a true and a true here, and that gives us a true. And a true and a true there, and that gives us a true. And these two will also be true. Okay, everything else is going to be false. So we can just go ahead and fill that in. All right. And now we're again doing the conditional for P implies R. So we're looking at these two columns right here. So this column and this column to get this column. Okay, so again with the conditional, true and false gives you a false. Everything else is true. So let's look for the true falses. So there's a true false. So this will be false. And this is a true false. So that's going to give us a false. And that's it. Everything else is true. Okay, and now we're going to compile. So we're looking at this column right here, and I'll go ahead and make it a star with a circle around it, and this column right here, and we're going to bring those two columns together with a conjunction right here. I mean, sorry, I said conjunction, I meant conditional. Okay, so with the conditional, if we have a true and then a false in that order, then we end up with a false. Let's look for that. So I don't see any of those, which means we don't have any falses, which means all of these are true. And so we do see the fact that all of these are true tells us that this is a tautology. And the tautology tells us that this is logically valid. Okay, now remember what I was saying at the beginning of the video. I'm not going to test you on knowing that this is valid via transitivity. I don't care about those names. What I care about is that you can construct all of this, that you can define your variables, create your statement, and then take your statement, put it into a truth table, and then use the truth table to identify the validity of it. Okay, and that's it for this problem.